Hello and welcome to episode 5 of how to program your Ti-84 or Ti-83 calculator. Today we're going to look at a special program called Cosine that I wrote. It has basically everything that we've gone over in the last 4 tutorials compiled into one program that can save you lots and lots of time in your computations. This program deals with sinusodial graphs. Sinusodial graph can be displayed by A, sine of B, x plus c times d. Now, what my program does is it takes the maximum point of a data set and the minimum point of a data set, and it finds the sine graph for the function and the cosine graph for the function. It finds A, B, the phase shift C, and the midline D. So I'm going to give you a quick run through of what this program does. It asks you for the max point first. So let's say it's at 0, 100. And let's say the minimum point is at 360, 0. It'll find the A, B, C, and D of the sine graph, and you press enter, it'll give you the A, B, C, and D of the cosine graph, including the phase shift. Now, how did I make this program? Well, let's go into edit and check it out. So the first thing this program starts out with is putting the calculator in radian mode to ensure that when I'm calculating these graphs, everything is used in radians, not in degrees, which is very important so you don't get crazy numbers. So first we use the basic display functions to display maximum point first and then your minimum point, so the user knows to put in your maximum point first and then your minimum point. It prompts them for EF, X, and Y, and then it does a series of calculations to find the A, B, and C, and D. I'm going to run through these really fast, so if you don't know what sinusodial graphs are, you can just skip over the next 30 seconds or 1 minute of the video. If you want to stay tuned and watch, it might be helpful for when you write your program. So first we want to find the amplitude. To do that, we find the absolute value of the two y values divided by 2. In this case, it's f and minus y. Get the absolute value of that and divide it by 2. Some people may be asking, well, how do I get the absolute value? Here's what I do. You press second, 0, which is your catalog. This is every single function in your calculator. The first one that you can select is absolute value. That's whatever you put inside of the parentheses will be found the absolute value of, and you store that into A. So we already found the A of our sine. Then we're going to find the absolute value of x minus e, store that into B, multiply that by 2, and find the new B so that we know how many x's we move. And then we do 2 pi over B to find the period of the graph. Then to find the midline, we take the minimum point and add the amplitude to find the midline. The heavy work comes when you want to find the phase shift. To find the phase shift, it's just a series of algebraic moving around variables to get this equation right here to find C. I then clear the home screen and output my sine cosine value. The output function is a very fun function to use, and that's why I'm showing you this program so you can learn how to use it. To find the output function, you go to Program, scroll over to Input Output, and it's number 6 down. Output takes 3 arguments. It takes 2 numbers and then whatever you want to output. The first number is the number line that you go down. So if you look at my mouse cursor right now, this is the first line, second line, third line, fourth line, fifth line, etc. So this output displays on the second line, comma, 1. The 1 means that it is the first place where you can put text on the second line. So if you follow my cursor, that means it'd go on the second line, 1, 2, and it'll go in the first place, which is right here, comma, and then you can display whatever you want to output. In this case, I want to say A equals. I then proceed to do that for the A, B, and C so that we can output the A, B, and C values. After that, I output the actual values of the variables. Here on line 4, space 5, I output the variable C. On line 5, space 5, I output D. I then pause, and this comes a little tricky part right here where I want to display also the cosine function of the graph. What just happened was I displayed the sine A, B, C, and D, but now I want to display the cosine. Now the one thing common in between sine and cosine is that the A, B, and D stay the same. The only thing that changes is the C. So in this case, I perform finding the phase shift again, only this time with cosine inverse instead of sine. I then output 1, 1, and I output cosine so the user knows that this is the cosine version of my graph. If you remember at the beginning of the program, I stored 1 into R to reset the variable R. So right here, I'm adding 1 more to R to make R equal 2. After I add R to 2, I go to O. Now, where is label O? Label O is right here, where yet again I output A equals, B equals, C equals, and D equals, and then I output my new variables yet again with the cosine values. At this point, r equals 2, where I display an if function. What this function does is it says if r equals 2, then go to e. So r does equal 2, so that means the program is going to go to e. If r did not equal 2, it would just skip over. So let's go down to e. At e, it clears the home screen and it stops the program. So that was a quick overview on how to use the output function and how you can use it to find a sinusoidal graph of cosine and sine of a data set. This program is one of my most favorite programs because it saved me some of the most amounts of time on my homework at home. If you want this program, you can email the link in the description, and I should email you back within a day because I check my email almost half an hour every single period of the day. Just email your name and tell me that you want the program, and I'll shoot it over to you as soon as I read the email. Thanks for watching, and have fun not doing work by hand.